As a former AFNHA AmeriCorps member myself, I'm really happy to be here and share some of the work that I've been involved in since my humble career beginnings with AmeriCorps back in 2014. And I'm going to talk about Mineland restoration and opportunities for pollinator habitat. Some of you may be familiar with the nonprofit tree planting organization, Green Forest Work. That's where I work now. For those of you that haven't heard of it, Green Forest Work restores healthy, productive, and ecologically functional forests on formerly surface coal-mined lands across Appalachia and now in Australia too. By converting reclaimed non-native grasslands and shrublands into healthy, productive forest land, Green Forest Work is addressing two needs of the region. Our reforestation projects provide jobs for equipment operators, nursery workers, and tree planters, and also improve the environment by eradicating non-native species and restoring ecosystem services. Since 2009, we've helped plant nearly 4 million trees across more than 6,200 acres, and a huge shout out to all of our many awesome partners who make this work possible. Surface mining for coal has left scars on landscapes and reduced ecosystem functions across Appalachia for over a century. Approximately 1 million acres of Appalachian forests have been removed due to surface mining. In 1977, mining laws changed. Dangerous issues like landslides, boulders coming down hills, as well as erosion and sedimentation of streams and unnatural high walls led to the 1977 law being passed. This law required the land to be pushed back to approximate original contour, required it to be heavily compacted to hold it all in place, and required the establishment of vegetation. All across Appalachia, these lands reclaimed after 1977 are known as legacy mines, and they're characterized by a state of arrested succession that they're left in. This means that native forests are not easily able to reestablish on them. There's several reasons that forests aren't growing back. Topsoils are buried and they're substituted with a mixture of rock from above and below the coal seam. This rock mixture lacks organic matter, nutrients, and water holding capacity conducive to forest growth. Heavy compaction of the land prevents water from filtering down through the rock, which is needed for oxygen and nutrient exchange. And the compaction prevents planted trees from establishing healthy root systems. During this era, lands that were to be reclaimed to forest were planted in monoculture plantations of disturbance-tolerant trees, most often not native to local ecosystems. But the trees that survived were highly stunted. More often, the trees were not surviving due to compaction, so they would need to be replanted. And it became much less expensive to reclaim the lands to grassland, pasture land, post-mining land use instead. Aggressive exotic grasses that were seeded outcompete native plants, and the heavy compaction of the land prevents the establishment of native trees and shrubs. So the land remains a grassland for many decades and may never become a functioning forest again without intervention. That's where Green Forest Work and our partners come in. It's these legacy mines that we are restoring and reforesting. I'm going to talk about, in particular, two Mineland restoration projects in West Virginia on the Monongahela National Forest. Some of you may be familiar with these Mineland restoration projects on Cheat Mountain. This is the Mauer Tract. It's on the Greenbrier Ranger District of Monongahela National Forest. Our ecological restoration work has been going on the Mauer Tract since 2009. And this is the district where I served as an AmeriCorps in 2014, after which I was hired on with the Forest Service as a biological technician with the Wildlife Program. This is Sharp Knob on the Marlinton White Sulphur District. This project started in 2018. Both of these sites are part of the biodiverse high elevation red spruce ecosystem, which used to cover all the high elevations of West Virginia. The minelands on Mauer and Sharp are fragmenting this red spruce northern hardwood ecosystem. The primary goal of the ecological restoration work that we're doing on Cheat Mountain is to restore red spruce forests, which support a high diversity of plants and wildlife, including endemic, sensitive, threatened, and endangered plants and wildlife. These projects aim to replace degraded minelands with red spruce forests. Planting forests promotes organic matter input and soil production, and trees sequester carbon to mitigate the effects of climate change. Goals of the restoration project also include watershed improvement, soil building, and enhancement of early successional habitat for wildlife, including pollinators. On Mauer and Sharp, post-mining landscapes look like this. They're either monoculture plantations of highly stunted, non-native and exotic trees, or grasslands that look like they're maintained pastures. These photos were both taken on the Mauer Tract 40 years after reclamation. The process of restoration begins with decompaction. This is a really critical step. On plantations, dozers push non-native and exotic trees aside before decompacting. And on the grasslands, of course, they can skip this step. The dozers decompact or rip the ground by pulling 3-foot ripping shanks behind them. You can kind of see it in this photograph down here behind the dozer. It's kind of like tilling your garden, but on a huge scale. The rips are spaced 6 to 8 feet apart, and this breaks the arrested succession and allows native vegetation to begin colonizing the site. Then they use an excavator to spread the large woody debris from the plantation trees back out over the land. The woody debris provides many benefits to a restoration, especially on hillsides. It helps to reduce erosion. When we plant trees in and around the woody debris, it provides microhabitat for those trees, reducing the effects of wind and weather events and hot and cold extremes. It builds kind of a barrier which really reduces tree browse by deer, because deer love eating our trees. It provides for wildlife and insects and pollinators. It provides shelter, perches for birds, and its habitat structure. And also, as the trees break down, it begins to build the organic layer on these sites. Often, ripping changes the hydrology of the mountain too. So an excavator creates wetlands and vernal pools where there is clay and water at the surface. Through this work, hundreds of vernal pools are constructed each year, and woody debris from non-native tree plantations is repurposed for habitat features in these wetlands. Next, the ripped land's ready to be planted the following spring. We plant trees of as many species native to red spruce northern hardwood ecosystems as we can get our hands on, half of which are red spruce, and species like bigtooth and quaking aspen, cucumber magnolia, mountain ash, serviceberry, hazelnut, elderberry, lots of species. We also plant wetland shrubs around the creative vernal pools, shrubs such as wild raisin, speckled alder, winterberry holly, chokecherry, dogwoods, and willow. Many of the trees and shrubs that we plant are flowering species that attract pollinators. The woody debris scattered over the former plantations provides shelter and hiding places for wildlife and insect pollinators. Mineland restoration is most often done on a very large scale to increase the efficiency of heavy machinery use. On mower and sharp combined, so far, we've restored from 90 to 265 acres per year. There's ample opportunity for habitat for pollinators, especially in the 15 to 20 or more years before the trees grow up and form a closed canopy. The ripped ground opens up the opportunity for native plants and trees to seed in from the adjacent forest. After working on the Greenbrier Ranger District for 4 years, I decided to go back to school. I was really fortunate to be able to study at the University of Kentucky under our Mineland Restoration partner, Dr. Chris Barton, the president and founder of Green Forest Work. I had the freedom to create my own research project, and because Mineland Restoration was my favorite project while working on the National Forest, I really wanted to focus my research on ways to enhance the overall ecological impact of our restoration work. First, I wanted to know what the impact of decompaction really was on the plant community that grows back. We'd noticed anecdotally that after ripping, many more species would pop up, lots of flowers too, and I had a suspicion that they were trapped in the seed bank due to compaction and competition with aggressive grasses. To find out what species were in the seed bank, I did a soil seed bank characterization. We took soil samples on a reclaimed grassland before decompaction, and I put these in a greenhouse at the University of Kentucky, grew them out in 2 rounds of roughly 4 months each, one for spring germination and one for fall. Then, with lots of help from Forest Service botanists and one of my thesis committee members at school, we did botany surveys on the Mauer Tract and identified all plants present on a non-ripped site, a ripped site, and in the adjacent native forest. Results of these botany surveys: on a site that had not been ripped yet, we found 45 species growing. On a site after being ripped, there were 108 species. In the greenhouse soil seed bank study, there were 55 species in the seed bank. And in the adjacent forest, there were 46 species. And I know we can't directly compare the adjacent forest, but I really was curious to find out if the native forest was seeding onto these sites adjacent to them. So decompaction increased native species richness by 63 species. And you can see that here, the yellow is the native species. I also looked at exotic and invasive species, but from the non-ripped to the ripped site, there was an increase, a big jump there. So that was really good news for us. Another part of my research was tapping into the opportunity that is the early successional habitat before trees are growing up into a canopy. While we planted thousands of trees and shrubs each year, I felt that herbaceous plants, which provide so many benefits to soil formation and wildlife habitat, were being underutilized. We were missing out on a big opportunity to increase native herbaceous flowering plants for pollinators on the Minelands. We had done some very small scale seeding over the years. While I was with the Forest Service, we used to have a native plant partnership with NRCS Plant Materials Center in Alderson, West Virginia, and we would collect native seeds all over Cheat Mountain and other high elevation diverse spots around the National Forest. Then we would help clean the seed, spread it in seed beds, pot up the seedlings, and then whatever grew, we would plant on the newly ripped minelands each year. Leftover seeds we would end up spreading out over the newest ripped site, and my coworker Todd and I would check on the seeded areas each year to see what was coming up. But we had never purchased seed to spread it on the minelands at a large scale. We weren't even quite sure which species would be able to grow in the harsh conditions on the rocky mines. We only had anecdotal evidence from our past seeding. To help us narrow down which species would be worth investing in to seed on a large scale, I did seed trials. National Forest ecologists and botanists helped me choose 10 species that are important to pollinators and the red spruce ecosystem, and there were 9 herbaceous and 1 woody species. To test for success of direct seeding on these decompacted mine soils. At the same time, I wanted to find out if there was a difference between seeding with and without protection by woody debris, so that we could learn which species to seed on bare ground versus in woody debris piles. I measured germination, cover, and survival of the seedlings. There were 6 plots per species. 3 of them were bare ground and 3 of them were covered with woody debris. So results of everything, looking at the red is the no wood group and the blue is the group with woody debris. Overall, there was higher germination when it was bare soil, but there was higher cover at the end of the first growing season under the woody debris. And then there was, this was exciting, we found statistical significance in the difference between the proportion survival of the whole group with woody debris versus without woody debris. And looking at the species individually for both bare ground and in woody debris piles, evening primrose and black-eyed Susan did best for both categories. I also did a side project to my research. We tried transplanting 4 native herbaceous flowering species important to pollinators. We planted them around constructed vernal pools on Sharp Knob and measured survival and cover. I tried Joe Pieweed, blue vervain, swamp milkweed, and boneset. Cover was a little bit all over the place, but these plants grow to different sizes, so that was okay. But survival was really high. We had between 59 and 80% just in the first growing season. And that was, even though when we were transplanting them, I ended up breaking many of these poor plants in half, but it actually seemed to stimulate their growth. We had great survival anyway, so I was happy with that. We've begun to ramp up our seeding efforts after decompacting these sites. We now seed on a large scale, spreading herbaceous plants that attract pollinators. This past spring, we had an Appalachian Conservation Corps, AmeriCorps group, that helped us seed 148 pounds of wetland, upland, and steep slope mixes over 19 acres. We walked 2 miles of ripped areas on Mauer and Sharp. We seeded 39 species of native grasses, legumes, and flowering plants important to pollinators. In summary, restoration tools that we use for Mineland restoration, decompacting the ground, utilizing woody debris, creating wetlands, planting native trees and shrubs, and seeding native species important to pollinators. All of these restoration techniques promote colonization by native plants and attract wildlife and pollinators who continue the restoration process for us long after we've completed these projects. The benefits of our work increase exponentially when we enhance wildlife and insect pollinator habitat. The woody debris provides shelter, perches for birds, hiding places, which attract more wildlife that feed on plants, insects, small mammals, and the birds and other wildlife help spread seed material from the adjacent native forest onto the ripped sites. We especially see the woody debris piles growing an abundance of species, many of which we did not plant, such as fire cherry, sumac, and many other natives that are consumed by mammals or birds. The insects and wildlife perpetuate the restoration process for us. There are 1 to 1.5 million acres of legacy minelands in Appalachia alone, and all of these acres have the potential to be pollinator habitat before trees grow up into the canopy. So we've got a lot more work to do. Thank you.